Hi and welcome to another episode of Qt QML tutorial. Today you will learn more about tree-based parenting system in Qt, about Q object trees, and why was it actually introduced to Qt framework. My name is Lukas Kosinski. I am the CEO at Sci Studio, Qt QML consulting company. We help our customers achieve their objectives by providing them with skilled Qt developers. You probably noticed that in the previous episode of the tutorial, we used QObject constructor and that it takes a pointer to another Q object. This is not without a reason. It is a pointer to a parent. But what is a parent? What is this whole parent-child relationship about? And why was it actually introduced? Short answer, memory management. Memory management is important aspect of C++ programming. There are many different solutions to make our work easier, but today we will focus on how Qt help us in this aspect with object life control using tree object hierarchy. Enjoy. C++ is known for precise memory management. It is what makes C++ so efficient, right? However, it adds more responsibilities. The biggest concern of C++ programmers is, of course, memory leaks. It's not about water leaking out of the computer, it's about making sure that objects allocated on the heap are removed at the right time. Unfortunately, or maybe for good, there is no such thing as a garbage collector in C++. Memory leak happens when you forget to deallocate memory allocated on the heap. This is the simplest example of a memory leak. You allocate something dynamically, but it's later not deleted. But what does memory leak actually cause? Imagine a situation where your application loads images dynamically into memory. Modern image formats can reach up to several megabytes in size. When you load thousands of such images as pointers, you have to remember to delete each of them. In case you skip any of the images, you have just created a serious memory leak. This reduces the stability of the program and entire system. It also prevents other programs from allocating the same memory areas, and it also exposes data to be attacked. For this reason, a Qt framework, through its most basic type, QObject, introduced a tree-based object hierarchy. How does it actually work? Each QObject can have one parent. That is why there is a parent argument in the constructor. Once the parent is set, that object is added to the parent's list of children. Also, each child can have its own list of children. When it is drawn, it looks like a tree. But how this Qt feature makes sense? QObject in its default destructor iterates through the children allocating each of them. In practice, this means that when you delete the parent, all children are deleted too. Then the children deallocate their children and so on. Effectively, this operation removes the entire branch of the object tree under the deallocated parent. You could say that a parent dying takes its children with it to the grave. This is not very responsible behavior for parent, but this is how it works in Qt. The key condition for this mechanism to work is to set the parent implicitly via the QObject constructor or explicitly via the setParent method of the QObject instance. Forgetting to do so will result in our QObject instance hanging around on the heap and waiting to be manually removed. Thanks to Qt's parenting system, the programmer at worst worries about deleting only one instance of the root QObject And at best, he can define the root Q object on the stack, so it will be deleted when it leaves the scope of its visibility, making memory management far easier. It is also worth adding here that Q objects by default have the copy constructor removed. This is because of the tree hierarchy, because of the parent-child relation. A Q object can have only one parent. Copying a class that has no children would not be a problem. It would be enough to add copies to the list of the children to parent. But what if the Q object already had children? That would require copying all of them, which would be firstly inefficient and then insecure. Additionally, when copying a child, we cannot set multiple parents for copied object, so we don't know which one to pick, the original or the copied one, right? So what we will do for coding example. Let's imagine an application that has many different windows. Each window can create sub-windows that work closely together. Closing one of the windows automatically closes all the sub-windows belonging to it. We'll write a class named application window based on QObject. It won't be a real window, but only a simple representation of it in the program's memory. Uh, we did not learn yet how to code GUI in Qt. And each window will have a title stored as a QString. In order to know when a window is open or closed, we will add some console output in the constructor and destructor. Then we will create multiple instances of application window, one root window, then two main windows, to which we will create several other instances of sub windows. Then we will simulate closing them, closing some of those windows using the Qt timer. Okay, let's start some coding. I have prepared an empty Qt project, which so far only has main CPP file, and it has base QCore application instance. Let's create application window class. As a reminder, right-click source files, choose add new, then C++ class, and now let's give it a name, application window. And now let's make it basing on QObject. I like to change the case. Next. Finish. And now we need to add our files to CMake lists. We copy their names by clicking yes. Then paste them as additional sources of project executable in CMake list file, and let's save. Okay, the class appeared in the project tree, so we can go further. Let's start by adding a private field mtitle, which will store the name of our window. Private qstring mtitle. Now we need to somehow pass it to the class, so we'll modify the constructor so it takes the window name as the first parameter. Now, notice that Qt Creator allows you to modify function parameters in the source file quickly. Just press Alt-Enter and choose Apply Function Signature Changes. You can find more shortcuts like this in our Qt Creator cheat sheet. Now, let's initialize our class member in constructor like this. Notice how the base class superclass constructor is called. We pass the optional parent argument, setting the parent implicitly. If the argument is not a null pointer, then the allocation of QObject parent will also take care of this object. Okay, so we have a constructor. Let's print the name of the newly created window here. We need to add QDebug header. And now we can print window name, window created, and title. Now we also need to know when the window is closed. So let's implement a destructor where we will inform about it. We create its a declaration header file, application window, and we press Alt plus Enter, and we can also choose the first option, and boom. Let's print the statement, debug statement here as well. Window closed. Okay, class is ready, and I think that we are good to go. Let's go to main CPP and let's create a simple window structure by allocating several windows on the heap. To do this, we need to import the appropriate headers. So first, let's include our class header application window, and let's include QTimer, which will be used later. The first window will be called root window, application window. Let's initialize it on the stack, so it will be deleted when application returns. Let's give it a name, root window, and we are not passing argument here. It will be deleted automatically when application exits. Parent is not needed for object created on stack. Let's create now sub windows. The first one will be named parent window 1, parent window 1, and let's initialize it on the heap using new keyword. It's going to have a string title parent window 1, and we pass reference to root window as a parent. Now let's do the same for the second parent window. We just copy it, we paste it, and let's just change the name. Okay, and now using a for loop, we will initialize 2 more children for each parent window. So let's write this int e, and now we allocate the first child window on the heap inside the loop. Application window, new application window, and for the names, let's use a QString constructor. I will name it child window, now argument of parent window 1. And now I can use arg function to update %1 value with the one passed to the function. In this case, it's iterator. Then we need to pass pointer to parent window 1 as the parent argument. And now the same for the second window. Let's just update the names. Okay, now we have that simple hierarchy of windows, so we can simulate closing one of the parent windows by deleting it. For that, let's use QTimer single shoot static method. This will allow us to implement a delay without QTimer object. The delay will be 5 seconds, and the second argument will be a lambda deleting parent window 1. Instead of using delete keyword from C++, we will use delete later method of QObject. This prevents the situation in which certain events sent by the object have not yet been fully processed by the application, but the object itself has already been deleted. Okay, so I guess that we are ready. Let's start the program. As you can see in the output, all window objects were created, and after equally 5 seconds, parent window 1 has been deleted, and with it also all children. And that's exactly how Qt object tree system works in Qt. We delete the parent, and even when the application runs, for example, when it's no longer needed, and along with the parent, all the things assigned to the parent, so its children, are simply deleted. So similarly, closing root window should close all parent windows, right? And all, of course, all the child windows. But wait, if the root window is allocated on the stack and it is parent of parent window 2, then closing the entire application should delete all remaining windows. Let's check it out. Instead of deleting parent window 1, we'll just close the application here. We'll use the quit method on app to do this. And now let's test it. After starting the app, all windows were created, and after 5 seconds, application exits and it closes all windows. You can see that all windows have been closed recursively. Yeah, so again, this is how memory management works in Qt framework. Of course, you can mix Qt parent system with raw and smart pointers. Qt also has own alternative for smart pointers. Yeah, and I hope you liked this episode. Thank you for watching. Feel free to subscribe to our YouTube channel because we are publishing also some other things here. And all the announcements about new things that we release are also posted on LinkedIn. So make sure that you follow us there as well. All the links will be in the description. In the next episode, we will talk about the magic behind the Qt framework, about a meta object compiler, why all the things like signals and slots actually work. See you.